We usually think of our operating systems, our Windows, our Mac OS, as these kind of passive backgrounds. They're just there to run our stuff. But what if that whole idea is wrong? Today, we're looking at Apex OS 1, a project that completely flips the script. It's an OS designed not just to sit there, but to actively, aggressively fight back. So let's start with that one big question. Really think about it. What if, when some new threat came knocking, your computer didn't just sit there hoping your antivirus would catch it? What if the OS itself could learn, adapt, and just shut that attack down all on its own? And the vision here is, well, it's audacious. It goes way beyond just self-defense. We're talking about a system that is constantly getting smarter, constantly evolving. And here's the really wild part. It has a whole economy built in to actually pay people for making it better. Now, this isn't some fly-by-night idea that just popped up. The founder, Gaetano Camparcola, started laying the groundwork for this all the way back in 2013. So that's more than a decade of deep architectural work, of partnering with real cybersecurity pros, all building up to what they're calling a whole new paradigm for security. Okay, so why do we even need a new paradigm? Why all the fuss? Well, it's because right now we're stuck in what you could call a losing arms race. The way we do security today, it's just not working. And here's the heart of the problem. Modern cybersecurity basically pits human beings against lightning-fast, automated attacks. And honestly, we're losing that fight. Our security teams are just drowning in alerts, there's a massive talent shortage, and all our tools are reactive. They only kick in after the damage has started. And this slide really shows the shift. You've got the old world on the left, reactive, a patchwork of different tools, with the human analyst being the ultimate bottleneck. But on the right, you see the new model. It's proactive. It's one unified system. And it's driven by an AI that doesn't just respond. It tries to predict and neutralize threats before they can even make a move. So how in the world does this thing actually work? Well, that brings us to the core of it all, the self-improving AI engine. We're going to see how a blockchain and AI and a whole community come together to create what the project calls a living defense. It really comes down to these three pillars. First, there's the Arwa blockchain, which is basically an unhackable public record of everything that happens. Then you have the Apex One AI. That's the autonomous brain doing all the work. And then you've got the secret sauce that holds it all together. This revolutionary idea they call proof of intelligence. So what exactly is proof of intelligence? Forget about proof of work, mining crypto by burning electricity. This is totally different. This is a system that pays you for doing work that verifiably makes the AI smarter. The analogy they use is just brilliant. Think of it like a global immune system. Every time you contribute a new antibody, like a piece of threat intel or a fix for a bug, you get rewarded for making the entire network stronger. So what does that look like day to day? Well, an expert, who they call an intelligencer, submits some work. The AI itself then looks it over, checks it for quality, and figures out how valuable it is. And once it's all verified, boom, the contributor gets rewarded with tokens. It's a perfect feedback loop. Human expertise sharpens the AI, and the system pays the human for their help. And they are not messing around with this incentive. Look at this. A full 50%, half of the entire token supply, is set aside for that proof of intelligence rewards pool. This is not some little add-on. This is the core economic engine of the whole project, designed to fuel this global immune system for the long haul. Okay, so you have this self-improving brain at the center of it all. How do you build the rest of the fortress around it? This gets us to section 3, building a truly unhackable OS. The goal is what they call a AAA grade architecture, and it's built on some really hardcore principles. The whole system is built on these 4 non-negotiable ideas. First, zero trust, which means you trust nobody and nothing by default. Second, capability-based security, and we'll talk more about that in a sec. Third is formal verification. That's using pure math to actually prove that the most critical pieces of code are perfect. And finally, post-quantum cryptography, to make sure the system is safe even from the quantum computers of the future. This quote is honestly the best way to understand capability-based security. On your normal computer, when you run an app, you're basically giving it the keys to your entire house. With this model, it's like giving that app a key that only opens the pantry, only works for 1 minute, and can't be copied. It's about giving everything the absolute minimum power it needs to do its job, and nothing more. And just to give you a sense of what a huge deal this post-quantum stuff is, look at these numbers. A normal signature today is about 70 bytes. The post-quantum version, almost 3,300 bytes. That is a massive difference, and it affects everything: your network speed, your storage. It just shows how committed they are to making this thing future-proof. Okay, so you've got this super secure OS. You have this AI brain sending out digital agents to hunt for threats. But how do those agents talk to each other? How do they report back without getting spotted by the very enemies they're hunting? You could encrypt the messages, sure. But what if you could do something even better? What if you could make it so that an observer wouldn't even know that a conversation was happening at all? What if the communication itself was just invisible? And this is where things get really, really wild. It's a protocol called shadow speak. Think of it like invisible ink for the entire internet. Instead of hiding a message in the code of a single file, it hides the message in the meaning between a whole sequence of seemingly normal actions. So imagine a secret command is spelled out by, I don't know, a specific comment on a YouTube video, followed by a like on an Instagram post, followed by a post on a forum. Each piece is innocent on its own, but together they form a message. It's almost impossible to detect. So let's pull all these threads together. A self-improving AI, a nearly unhackable OS, invisible communication. What's the big picture? What does this all mean for us? That brings us to our final section, democratizing digital safety. When you boil it all down, the end game is this: to create a living, evolving, self-sustaining defense network. It's about taking the kind of security that has historically only been available to governments and massive corporations and making it accessible to absolutely everyone through an autonomous system. Which really leaves us with one final, pretty profound question. We're so used to our security being a tool, something we point and click. This project imagines a future where our digital guardian is more like an intelligent partner, one that grows and evolves right alongside the threats. It's a complete change in how we relate to our technology. So the question isn't just if the tech is ready for us, it's, are we ready for it?